Good morning. Today, we are going to see about the information technology applications in the restructured power market. In short form, we can call it as IT applications in the restructured power markets. Why is IT information technology so important in the restructured markets? Say, for example, if you take traditionally in India, so utilities own generation, transmission, and distribution. So the power scheduling and billing were almost manual. So limited consumer choices is there, and also low transparency in the billing also will be there. So that is was previously vertically integrated market. So after the reforms, what happened after the restructured power system, power market, multiple generate compete, power exchanges operates open as a system that the consumer is existing. Next, the grid operation must be at real time. Settlement is accurate. So IT systems are backbone that makes the competition and reliability possible. So for all these things, say for example, sending the data, we need internet. So information technology related services is needed. Okay, is the backbone of this competitive market or restructured market or deregulated power market. What are the major categories of IT applications? So if you take like IT tools in the power markets, it is broadly divided into five broad groups. First is market operation and trading, grid management and automation, energy accounting and billing, analytics and simulation. Next, the fifth one is financial system and compliances. So, if you take like market operation and trading, so these system run India's power exchanges. So these system only is running the India's power exchanges. If you take like a day ahead market, real time market. So what this information technology does here? So, if information technology is not here, you can't manage all these things because bidding. So, everything nowadays, bidding also made in the websites. So, whoever the generation companies, generators and sellers also accepting the bids in websites only. So it clears the markets by using the algorithm. So prediction, load prediction, load forecasting. Okay, so everything the prediction based on the some algorithms. So for that also we need information technology services. Next, we are all publishing the prices in the online. So for that also IT related services needed. Next, by using the smart energy meters. So what we are doing is we are sending the schedules to the state load dispatch center and as well as the regional load dispatch center. So schedules also from the from the dispatching center to sorry generation companies from the dispatching centers to generators, they are sending the schedules. So schedules how many hours this particular generators has to be run. So every schedules we are sending in the online. So, and also handles the congestion splitting. So, this information technology plays a vital role in this restructured power market. That means backbone of the this restructured power market. This information technology services are they are doing all these things. Next, if you take like key markets, day ahead market, real time market, term again market, green market, so, what are the time horizon and what is the role of IT, information technology here? Say, for example, if you take like the DAM, that means day ahead market. So, the time horizon is for next day, whatever the schedule is going to happen, that today itself we are maintaining this scheduling. So, bid collection, we need to collect the bid from the generating companies. Next, market clearing. Okay, market clearing price also we need to decide. Next, congestion management, that also we need to simulate. Next, price calculation. What is the based on the market? We need to calculate the tariff calculation, price calculation, everything we are doing. So IT role is the backbone beyond this day ahead market also. So if you take like real time market, so her time horizon same day, okay, in the same day and near real time. That means 15 minutes once that data is being updated. So fast bid matching. Okay, so which generator is bidding low? So we need to find out the whoever quoted less. So for that, we need some computer related information related softwares behind that or machine learning based softwares as to predict so which is least cost bid, who are bid the least cost. So based on that, they need to give the contracts. So fast bid matching should be there. Real time balancing, that means demand balancing or load balancing will be there. Next, deviation settlement. Say, for example, any frequency deviation is there. Next, immediately you need to send the feedback to the online generators. So for that also, we need to send the data. So internet is needed. Okay, so and dispatch instruction. So what are what time the dispatch the scheduling has to be done for which thermal generators, 12 hours, hydro generators 8 hours, renewable generators 6 hours, like that. We need to schedule that generator generating system also. So for that, we need this IT related services. Next, if you take like term again market, TAM. So it is based on weekly, monthly, and long term. So contract management, bilateral contracts we need to maintain, scheduling, risk assessment. So what are the risk in that particular contract? So that also predicting thing. Next is settlement, price settlements. So everything we need to manage the backbone beyond this. We need the IT related services. Next, the green market. That means renewable energy trading market. Okay, time horizon. It is depends on the climatic condition, wind velocity, like that. So renewable certificate tracking. Okay, that one also we need this IT role of IT, information technology. Next, forecasting integration. So based on the, say for example, how much time today you need to run the wind generating units, how much time you need to run the solar panels, like that. That forecasting also you can get it from some softwares or machine learning based methods. So for that also we need this information technology based services. Next, compliance monitoring, settlements, everything we have to make backbone is this information technology based services. Next, grid management and automation. So these systems keeps the physical grid stable. Okay, grid management system. Say for example, if you take like a supervisory control and a data acquisition system and substation automation. Nowadays, substation also got automated. So it is collecting real-time voltage flows, power flows, and sending the data directly to the load dispatch center, regional load dispatch center. So regional load dispatch center, internet is connected with the state load dispatch center. State load dispatch center, it is connected to the national. So everything data and all, we are connecting by using this particular information related services, information technology related services. So SCADA and substation automation, if you take like it collects the real-time voltage balances for flows, control breakers. It controls the breakers also, switches also you can control. By sitting here in the substation, you can control the distribution transformer. Because in distribution transformer also, data will be keep on monitoring what is the voltage flow in the system, what is the load. Everything is monitored in the substation. Next, alarm, say for example, frequency suddenly it is down. Suddenly alarm gets power. So voltage profile is not matching. Next, alarm. It's like that. So that system also information technology related services needed. So enabling the fast operator response. So there will be not any operators to operate your circuit breakers and all. So fast operation. So for that, we need to send the data to the cloud, and from that they need to take from the load dispatch center like that. So for that also we need this information technology related service. Next, if you take like a outage management system. Okay, so pinpoint fault location. So where exactly fault is being located. So previously, if you want to locate the fault, some lineman has to go to that particular fault, and he has to intimate. Then they need to go come up with the material, what kind of fault, insulation failure or transformer fault, like that. The transformer changing. So like that, many things we need to do now. Like identify a pinpoint fault location can be detected in the SCADA system itself. Okay, where exactly this particular location. So in that particular near to this substation the fault happened. So substation, so if it is a major fault they need to go and attend. So if it is a minor fault, tripping only, it got tripped means easily you can on by sitting here itself. So for that data we need to send them. Okay, then only that circuit breaker will operate. Okay, so this kind of pinpoint fault location also possible. Next, estimate the restoration time. So if based on the fault, you can easily identify the what is the time taken to, such that you can intimate the consumers via some messages. Power interruption happens for 5 minutes. It will be rectified within 5 minutes. Like that, you can intimate to consumers. Next, inform the consumers by using SMS messaging services or using the WhatsApp message, auto bot. Nowadays, auto bot is there. Immediately send the messages to the consumers. Like that. Next comes the Geographic Information System, GIS. So nowadays, every system is connected to maps. Okay, so grid maps. If you take like grid maps, state grid maps, regional grid maps, all are connected with the GIS, Geographic Information System. So if you want to locate the particular transmission tower, say for example, 49th transmission tower, I need to locate. So based on the longitudinal, latitudinal location, you can easily identify where that transmission tower is being placed, and where the line exactly. What is the location of the particular transformer, distribution transformer, or switching substation transformer. Like that, easily you can locate. Based on that, you can connect to the transformer and you can receive the data. Take the data, and the data will be sent 15 minutes once. So, which supports the asset management also. Say, for example, sometimes this many transformers are there under the substation. Some 40 transformers are there under the substation. So what is the location? So somebody new, the service member is going to that area. So previously some worker has to go along with them, and they need to locate that particular transformer and all. So nowadays, if you send the location easily, they will go and. So previously, some maps will be there. Okay, so maps like distribution maps will be there. Based on that, linemans will go to that particular place. Nowadays, it's just based on GIS location. So this particular location, this distribution transformer is available. This pole is available in this particular part. Like that, easily you can identify that particular transformers, poles, lines. So which helps the helps during the storms and disasters. So sometimes some heavy storm is going to come. So that time you need to shut down that particular whole uh, line for some 10 kilometers, like that. For example, I'm telling. So if say for example sometimes they need to go there. So simply by sitting here you can switch off that particular. So this particular GIS based, okay, this latitudinal, longitudinal, this poles, based on that location are easily known. So this location is all you can switch off. Okay, for sometimes some 5 hours we can switch off. After storm we can supply the power. Like that also it is possible. Next, disaster hardening, you can easily identify this which part is gone. So such that in some other part, how can we provide supply the power to that particular area? That also locating is very easy in this GIS. Next comes the energy accounting and so if you take like smart meters, smart energy meters, automated meter recorder. So here recording. So here measures the energy in 15 minutes block time. Okay. So and also communicates automatically, enables time of day tariffs. Say for example, what is today's load consumption? What is today's tariff? That also easily you can monitor. Next, it also reducing the theft. Say for example, remote places some theft is happening. Easily you can identify, okay, the theft is because you know the load approximately. Say for example, if the suddenly load is increasing, so it will not increase just like that. Okay, if any festivals are there, just simply it will increase. But if suddenly load is increasing like anything, then that also easily can be monitored. Next comes the consumer information system. So, which stores the consumer's records in that particular, for that IT related based services, consumer information. So this many consumers in India, if you take 70 crores subscriber consumers are there. So, for that database, you need to maintain. So, which stores the consumer? So, cloud is needed. So, you need to maintain a cloud to store the data for that. So, for example, if they want to check the previous year records, 2 years records, 3 years records, that information will be available. Okay, monthly records also will be available. Daily records also will be available. So, generating bills is very easy. So, for that also information system is needed. Okay, so if you see in the consumer portal, you can get the demand curve. Okay, how much curve, demand, load demand curve, load duration curve, and all you can see. Okay, in which time load is consumed at the peak. To the peak. So in which time load is consumed very less. Like that, easily you can monitor and easily you can calculate your bills also. Okay, you can cross verify your bills also. And sometimes if you want to make a complaint, you can make a complaint in that information based system. And mobile apps nowadays, mobile apps, same thing. Whatever available in the website, that is given to your mobile app. So easily you can monitor anywhere in the world. Okay. Next comes the advanced analytics and the simulation. So, load forecasting. Nowadays, load forecasting also done by the some machine learning based techniques. So, predict the next day or seasonal demand, and which helps the procurement planning. Okay, procurement planning. How much we need to procure the power for tomorrow's load demand. Like that, easily you can forecast, and also which avoids the load shedding. Otherwise, what happens if you not forecast correctly, predicting correctly? So 99% it will predict correctly, 1% plus or minus it will go. Sometimes in that particular time you need to immediately react based on the renewable sources. Sometimes it might be dropping. Sometimes very few times. So based on that you need to match that particular. Next comes the optimal power flow and market simulation. So for that also we need information, some software specific optimization techniques and machine learning based prediction techniques. Calculate the optimal dispatch, how much dispatch optimally you can dispatch the power in that particular buses between these two buses. So you can easily simulate them. Okay, so this is the capacity. So maximum how much power you can dispatch in that particular area. Next, and also which detects the congestion also in that particular. It can be easily monitored because everything is connected to the GIS system. No, so easily monitor which tower the congestion is happening, or which area the congestion is happening, which location, particular latitudinal, longitudinal location that the congestion is happening, which area. Easily you can, and which is used for a transmission plan. So for that also we need this IT related based services. Next, the machine learning technique, as I said, availability, transfer capability, available So that also estimation you can easily that fault prediction. So if the fault, this line to ground fault happens, what will be the current changes? If a line fault happens, what will be the current? So triple line to ground fault, what will be the current? Like that, based on that, you can simulate. So if the current is rising suddenly, you can easily identify, okay, which kind of fault, such that you can send your workers to that particular place. Okay, so such that the fault identification and the rectification will be very easy and in the very fast manner. Next comes the renewable forecasting. Okay, so based output forecasting also will be very easy in machine learning based techniques. Next, operational IT versus market IT. Okay, so grid operated IT and market based IT operation. So, what are the main the features if you take like purpose? So, what is the operated IT related services to maintain the reliability? Market based needs to enable the trading in an efficient manner. Next, if you take like examples, grid operation related IT service, SCADA, it is mostly used. Next, monitoring services, online monitoring services. Next, uh, daily agate market, real-time market platforms. So it is used. Next, time scales. If you take like grid operation, seconds to minutes. Okay, so second by second, the grid is maintaining the that or within 1 minute, it will give you the what is the particular grid frequency, grid voltage profile, everything you can easily monitor in that particular sense. If you take like a market based 15 minutes once, it will be updating. Okay, so these also IT related services are needed. Next, to users, if you take like a grid operation load dispatch, so you can easily communicate the load dispatches by using IT based software systems. Okay, related. You need to send the data no, to particular generators. Next, market based operation. If you take like traders wants this IT related base service. Then only like 15 minutes once they can know the data based on that they can easily know which transmission users we need to get the supply, which generator companies we need to contact and to get the power, consume the power. So which ISOs we need to contact such that we can get that this much of power. Like next, if you take like regulatory load, grid operated is indirect, market operated IT related services directly can regulate the market piece. Grid operated regulatory might be somewhat indirectly you need to maintain. So these are the some of the features and comparison between the grid operated IT related service and market operated IT related service. So the technologies driving this digital transformation. Say for example, if you take like artificial intelligence based algorithms, machine learning based algorithms. So mainly it is used for predictive maintenance, so which avoids the failures, and also renewable forecasting, which reduces the reserves. Sometimes if you are not forecast well, then you need to maintain the reserves, or otherwise you need to run the reserve generators on. So you can avoid if you forecast correctly, perfectly, you can avoid this results. Next comes the availability transfer capability. Available transfer capability calculations also is faster. If you do manual calculation, it will take more hours. So if you do with the artificial intelligence based technique, within some seconds you can get so more faster. Fraud detection. Okay, so fault detection, or if like anybody using the power theft is happening. So that also you can easily monitor, and also that also reduces the losses for that particular. So any losses happening to that particular transmission companies or distribution companies due to this power theft, that also can be reduced by using this kind of technologies, because minute by minute this information is being transmitted to that particular substation, so that easily you can monitor. So these are the important application of this artificial and machine learning based thing in markets, power markets, or restricted power markets. Next, if we take like cloud computing, so it also handles the huge data volumes. Okay, so number of users will be more, means it will handle the volumes. Okay, that much. Say for example, 70 crores, like users, consumers will is there. So how to maintain the database? So that much cloud also it has to be. You need to maintain the cloud data also. Okay. Next, it reduces the information technology capital cost. That also reduces. Next, which enables the nationwide platforms. You can maintain the nationwide platforms. You can maintain, and also supports the disaster recovery. Okay, any disaster recovery, that also cloud computing, by using cloud computing it is possible. Next comes the blockchain based emerging technologies. So, what are the main use of this blockchain technology? So, blockchain technology is rapidly emerging as a transformative tool, that is, an information related tool in the energy sector, shifting it towards a more decentralized, transparent, and efficient model. Okay, by acting as an immutable shared ledger, blockchain enables secure real-time tracking and automated transactions. So this is also possible in blockchain. So what are the potential application? Energy trading settlements. So we can use this blockchain technology. Next, renewable certifications. That also. Next, peer-to-peer market. Okay, this market to that market, peer-to-peer market. So from starting of the market to ending of the market, that connectivity you can make it by using the this blockchain technology. That means it is a more decentralized and a transparent and efficient model. So it is maintaining all your ledger, okay, secure services, real-time tracking, automated transaction certification is possible. Okay, audit-proof records, that also you can maintain by using this blockchain technology. Next comes the strategic impact on the Indian power sector. So, what are the IT related based service? So, information technology. What is the strategic impact of information technology on this Indian power sector? Okay, so how this IT improves the this power sector market, so which reduces the losses, improves the transparencies. Okay, so losses for your markets, that means transmission companies or distribution companies or generation companies will be reduced. Next, improves the transparency in the, anyone can see any data and you can analyze and compare. Next, enables the competition in the market, helps the distribution companies finances, that also financial thing also will be maintained. That means optimal, based on the optimal usage, you can cut the losses. You can reduce the losses for the distribution companies, reduce the outages also, because minute by minute this transaction is possible. Next, prediction is very exact. So outages we can reduce. There will be no power cut or power shutdown due to any failures. So supports renewable integration, that is also needed. Next, what are the challenges in implementing this information technology? If you take like cost, that utility has to maintain the cost. Next, skilled training trainer is needed, because any fault happens, skilled trainer is needed to rectify that fault. Next, the cyber security, you need to that one. So anybody should not hack your data, and they should not change your data. Okay, so that is also cyber security you need to maintain. Legacy systems, so integration problems, that also you need to maintain. Data standards, that uniformity has to be maintained throughout the states or throughout the country. That data standards you need to maintain. Next comes the traditional versus IT driven power sector. Okay, so traditional power sector, IT driven power sector. So if you take like a, in traditional system, meter reading is manual, but in IT driven system, it is smart. Market clearing will be traditional system limited. IT based system is based on algorithmic, that means AI based or ML based system. outage detection. We take like traditional system based on the consumer calls. Okay, in IT division, the outage management system is being monitored. So easily you can monitor where the outage happens and easily you can clear the fault. Next, if you take like in traditional system, billing made on the paper. In an IT driven system, it is entirely purely digital. Transparency, traditional system is low. In IT driven system is high. Transparency, everyone can go and see the what is the data, what is happening in the real power market. But in the traditional system, transparency you can see, but limited data only you can see in the